So welcome back with new questions. So today we'll solve some problems related to GATE engineering, GATE civil engineering previous year questions. Subject open channel hydraulics. Previously I have solved 6 questions from 1 to 6. So today we'll move ahead from 7 to 10. We'll see today 4 questions. So question 1, 2, 3, 4, 5 and 6 I have already solved. If anyone interested, please go the previous videos, the same channel. And the video is recorded in Hindi as well as in English, so separate playlist is available on the channel. If anyone interested with the Hindi, please go with the Hindi playlist. So now moving ahead with the question number 7. So in deriving the equation for the hydraulic jump in the rectangular channel in term of conjugate depth and the initial fluid number. So basically the question is about if you want to derive the hydraulic jump equations. The equation is look like that the y2 divided by y1 1 by 2 root under 1 plus 8 fr1 square minus 1. So the equation look like that. If you want to derive such kind of equation, so how you will what will be your the basic or you can say the fundamentals equations or fundamental concept or fundamental laws. So basically we know already there are three fundamental laws. One is the mass conservation, another is the conservation of momentum, and last one is the conservation of energy. Whether we can use here the conservation of energy or not, whether we can use here the conservation of momentum or not, let us discuss. So the question is hydraulic jump, related to hydraulic jump. So here y1 and y2, you need to calculate the relation between y1 and y2 like that. How you will derive? So here in the jump, you know already some energy is losses. If energy is losses and you don't know how much energy losses, so you cannot apply directly the conservation of energy here. So but you can apply here conservation of momentum. Why? Because of the not need the energy in the uh, momentum equations. Momentum equation is nothing but Newton's second law. If anyone interested, please let me know through comment. I will explain more with the derivation, all derivation. So now let us discuss. So one equation you can use here the momentum equation, and another equation you can use the continuity equation. Anyway, continuity equation we can apply because here the mass is conserved. So inflow discharge and outflow discharge will be, if we take the cross section here, so inflow here and outflow here, so inflow and outflow discharge will be same. So we can apply here two equations. One is the momentum equation and another is the continuity equation. Why we cannot use the energy equation? Because of the energy losses in the formation of jump. So option B will be correct for that. Continuity equation as well as momentum equation you can use. A section in open channel at which a fixed relationship exists between the discharge and the depth flow. Fixed relationship. So you can say here as directly proportional to y to the power n. When you will remove proportionality, see some constant and your relation will look like that. So always this is fixed, means your constant will be fixed. So what will be your so such kind of section, it is a particular name of such kind of section. So what is the name? So we know as generally as the control section, or also you can write the nodal section. Basically generally in the river engineering we always use this nodal section or control section also. So how it look like? If your like your channel is like that, so somewhere you make some structure for measuring the discharge. So at a particular point your discharge and depth relationship will be the constant. So such type of section we know the control section. Now moving ahead on the next question, flow at a critical depth take place in an open channel when? So before moving on the options, if we draw the diagram of a specific energy versus depth of the flow, specific energy diagram for a particular discharge. So this depth is known as your critical depth, and this energy is known as critical energy, right? So in question, now read again question. Flow at a critical depth take place in an open channel when discharge will be constant and your energy should be minimum. After that, if you minimize your energy, what will happen? There is no flow, because for flow your energy lines should be lie on the this graph. So minimum energy is critical energy. So you read one by one the options. For a given specific energy, discharge is maximum. This is wrong. For a given discharge, yes, a specific energy is minimum. Option B will be correct for that. Now moving ahead on the next question. The water surface profile resulting from flow underneath the gate in the figure is. Okay, so this is the gate. So water is flowing like that. This is the water surface profile. Water surface is going upward direction. So what is H1, what is H2, what is H3? If you don't know, please let me know through the comment. And for just write explain little bit more about H1, H2, H3. If you will write that thing, then I will definitely I will make a full length video for the profiling, that is M1, M2, M3, S1, S2, S3 and H1, not H1. H1 actually doesn't exist, and how how is it possible H1 not exist and S2 exist, H3 exists. So we can go through the several interpretations. I will come later, but for sake of time, so S here is the bed is horizontal, so S2 not possible. Whether H1 not possible, it may be H3 or it may be H2. So you know already H2 profile is falling profile and H3 profile is a upward profile. So here is water surface is going upward direction. So option A will be correct for that. So thank you for today. We'll meet again next day. If you want more detail about that, please comment in the comment section. So thank you again.